Section 810.21 of the National Electrical Code, specifically the 2008 edition, mandates the grounding of radio towers or masts. This requirement is in place to ensure safety and prevent electrical hazards. One acceptable method for grounding a radio tower involves bonding it directly to a steel tank, provided the steel tank itself is properly grounded. The crucial aspect here is that the steel tank must have a reliable connection to the earth. This can be achieved through various means, such as a connection to the building's grounding electrode system or a dedicated grounding electrode like a ground rod or ground plate. The connection between the radio tower and the steel tank can be made in one of two ways: firstly, by using a separate grounding conductor, or secondly, by utilizing the rigid steel conduit that houses the Cat5 Ethernet cable as the grounding conductor. If a separate grounding conductor is chosen, it must be sized according to Table 250.122 in the National Electrical Code. This table provides specific guidelines for the minimum size of grounding conductors based on the size of the overcurrent protective device protecting the circuit. For example, if the circuit supplying power to the radio equipment is protected by a 20 amp breaker, Table 250.122 would dictate the minimum size of the grounding conductor required. It is essential to consult the table carefully to ensure that the correct size conductor is used. The grounding conductor, whether it is a separate conductor or the rigid steel conduit, must be connected to the grounding electrode system at the service entrance. The service entrance is the point where electrical power enters the building from the utility company. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or the building's metal water pipe. The connection to the grounding electrode system must be made in a manner that ensures a low impedance path to ground. This is important for effectively dissipating fault currents and minimizing the risk of electrical shock. When using rigid steel conduit as the grounding conductor, it is imperative to ensure that the conduit is properly bonded to both the radio mast at the top and the ground rod at the tank base. Bonding refers to the process of creating a low impedance connection between two metallic parts. This is typically achieved by using bonding jumpers or bonding lockouts. At the radio mast, the conduit should be securely bonded to the mast using a suitable bonding connector. This connector should be listed for grounding purposes and should be installed in accordance with the manufacturer's instructions. At the tank base, the conduit should be bonded to the ground rod using a similar bonding connector. The ground rod itself should be installed in accordance with the National Electrical Code requirements, including minimum depth and spacing. In addition to bonding the conduit to the radio mast and the ground rod, it is also important to ensure that all conduit joints are properly tightened. Loose conduit joints can create high resistance connections, which can impair the effectiveness of the grounding system. It is recommended to use a pipe wrench to tighten the conduit joint securely. Furthermore, it is advisable to apply an antioxidant compound to the conduit threads before tightening the joints. This compound helps to prevent corrosion and ensures a good electrical connection. In summary, the National Electrical Code permits the use of rigid steel conduit as a grounding conductor for radio masts, provided that the conduit is properly bonded to the radio mast at the top, the ground rod at the tank base, and that all conduit joints are tightly secured. However, it is crucial to ensure that the steel tank itself is adequately grounded and that the grounding conductor or conduit is connected to the grounding electrode system at the service entrance. By following these guidelines, you can ensure that your radio mast is properly grounded and that you are in compliance with the National Electrical Code requirements. Always consult with a qualified electrician or electrical inspector if you have any questions or concerns about grounding your radio mast. They can provide expert guidance and ensure that your installation meets all applicable codes and standards. It's also important to consider the specific requirements of the 2008 National Electrical Code, as subsequent editions may have different or updated regulations. Therefore, referencing the relevant sections of the code book is always the best practice. Grounding is a critical safety measure, and it should never be taken lightly. A properly grounded radio mast can help to protect you, your equipment, and your property from electrical hazards. Remember to always de-energize circuits before working on electrical equipment and to follow all applicable safety precautions. Improper grounding can lead to electric shock, fire, and equipment damage. Taking the time to ground your radio mast correctly is an investment in safety and peace of mind. In addition to the points already discussed, several other factors can influence the effectiveness of a radio mast grounding system. These include the soil conditions at the installation site, the length of the grounding conductors, and the presence of other metallic structures in the vicinity. Soil conditions play a significant role in the performance of a grounding system. Soil with high moisture content and a high concentration of dissolved salts is generally more conductive than dry, sandy soil. Therefore, grounding systems installed in areas with conductive soil tend to be more effective. If the soil at your installation site is not very conductive, you may need to install additional ground rods or use a ground-enhancing compound to improve the grounding system's performance. The length of the grounding conductors can also affect the grounding system's effectiveness. Longer grounding conductors have higher impedance, which can reduce the amount of fault current that flows to ground. Therefore, it is important to keep grounding conductors as short and direct as possible. Avoid unnecessary bends or loops in the grounding conductors. The presence of other metallic structures in the vicinity of the radio mast can also affect the grounding system. If there are other grounded metallic structures nearby, such as fences, pipelines, or other buildings, they can create parallel paths for fault current to flow. This can reduce the amount of current that flows through the intended grounding path, potentially compromising the effectiveness of the grounding system. To minimize this effect, it is important to bond all nearby metallic structures to the grounding system. This will ensure that fault current has a clear and direct path to ground. In addition to the National Electrical Code, other codes and standards may also apply to radio mast grounding systems. These may include local building codes, communication tower standards, and industry best practices. It is important to consult with your local authorities and industry experts to determine which codes and standards apply to your specific installation. Furthermore, regular inspection and maintenance of the grounding system are essential to ensure its continued effectiveness. Grounding connections can corrode over time, especially in harsh environments. Ground rods can also become loose or damaged. Therefore, it is important to periodically inspect the grounding system for any signs of corrosion, damage, or loose connections. Any problems should be corrected promptly to maintain the integrity of the grounding system. When inspecting the grounding system, pay particular attention to the grounding connections at the radio mast, the steel tank, and the grounding electrode system. Check for any signs of corrosion, such as rust or discoloration. Tighten any loose connections and replace any damaged components. You may also want to consider testing the grounding system's resistance to ensure that it is within acceptable limits. A ground resistance tester can be used to measure the resistance of the grounding system. If the resistance is too high, it may indicate a problem with the grounding connections or the grounding electrodes. Finally, it is important to keep accurate records of all grounding system inspections, maintenance, and repairs. These records can be helpful for tracking the performance of the grounding system over time and for identifying any potential problems. Grounding systems are critical for protecting people and equipment from electrical hazards. By following the guidelines in the National Electrical Code and other applicable codes and standards, and by performing regular inspection and maintenance, you can ensure that your radio mast grounding system is effective and reliable. Always remember to prioritize safety when working with electrical equipment and to consult with qualified professionals if you have any questions or concerns. The proper selection of grounding conductors is also important. While Table 250.122 provides minimum sizes, there may be situations where larger conductors are warranted. For example, if the radio equipment is particularly sensitive to voltage fluctuations, a larger grounding conductor may be necessary to minimize ground impedance and ensure stable ground reference. The material of the grounding conductor is also a consideration. Copper conductors are generally preferred due to their high conductivity and resistance to corrosion. However, aluminum conductors can also be used, provided that they are properly sized and installed. Aluminum conductors have a higher resistance than copper conductors, so they must be larger to carry the same amount of current. Furthermore, aluminum conductors are more susceptible to corrosion than copper conductors, so they must be protected from moisture and contaminant. When connecting grounding conductors, it is important to use listed connectors that are specifically designed for grounding purposes. These connectors are designed to provide a secure and reliable electrical connection and to resist corrosion. Avoid using wire nuts or other general-purpose connectors for grounding connections. These connectors may not be able to withstand the high fault currents that could occur during a ground fault. The location of the grounding electrode system is also important. The grounding electrode system should be located as close as possible to the service entrance. This will minimize the length of the grounding conductors and reduce the overall impedance of the grounding system. The grounding electrode system should also be located in an area that is accessible for inspection and maintenance. Avoid locating the grounding electrode system in areas that are prone to flooding or that are difficult to access. In some cases, it may be necessary to install multiple grounding electrodes to achieve the desired grounding resistance. The National Electrical Code specifies the minimum spacing between grounding electrodes. Grounding electrodes should be spaced at least 6 feet apart to avoid reducing their effectiveness. If multiple grounding electrodes are used, they should be connected together with a grounding electrode conductor. The grounding electrode conductor should be sized in accordance with Table 250.66 in the National Electrical Code. In addition to the grounding electrode system, the National Electrical Code also requires the installation of bonding jumpers to bond together all metal parts that are likely to become energized. Bonding jumpers are used to connect metal enclosures, metal raceways, and other metal parts to the grounding system. This helps to ensure that all metal parts are at the same potential, which reduces the risk of electric shock. Bonding jumpers should be sized in accordance with Table 250.102 in the National Electrical Code. When installing bonding jumpers, it is important to ensure that they are securely connected to the metal parts. Bonding jumpers should be connected to clean, bare metal surfaces. Avoid connecting bonding jumpers to painted or corroded surfaces. It is also important to protect bonding jumpers from mechanical damage. Bonding jumpers should be routed in a manner that prevents them from being cut, abraded, or otherwise damaged. In addition to the requirements in the National Electrical Code, there may be other local codes or regulations that apply to radio mast grounding systems. It is important to check with your local authorities to determine which codes and regulations apply in your area. The proper grounding of a radio mast is essential for safety. By following the guidelines in the National Electrical Code and other applicable codes and standards, you can ensure that your radio mast is properly grounded and that you are protected from electrical hazards. Always consult with a qualified electrician or electrical inspector if you have any questions or concerns about grounding your radio mast.